Power of 3 is a very similar problem to power of 2, except as you can probably guess, instead of returning true if n is a power of 2, we're going to return true if n is a power of 3. So you could create a solution similar to the first one I did in the power of 2 video where you use loops or recursion, and that would also work for power of 3. But this problem also has a follow-up that asks if you can do it without loops or recursion. So I want to show another way that we can solve this type of problem using a more math-heavy approach that we'll see also works for the similar problem, power of 4. So we're trying to figure out if there's some integer x where 3 to the x power is equal to the number we're given n. If there is, then we return true, and if there's not, we return false. In other words, how do we know if n is a power of 3? Well, if x is a whole number, then n is a power of 3. So the question becomes, given n, how do we know if x is a whole number? Well, let's try rearranging this equation using some properties of exponents and logarithms. Because whenever we have some number a to the x power and we know it's equal to y, another way of writing that is log base a of y is equal to x. So we can rewrite 3 to the x equals n as log base 3 of n is equal to x. So now that we've isolated x on the right side of the equation, to figure out if x is a whole number, we can just try rounding x, and if we take the rounded version of x and subtract x from it, if x is a whole number, then this will equal 0. But there is a little quirk we have to account for. Since we're programming and floating point operations aren't perfectly accurate, we're actually going to check if this is just really close to 0. For example, we know 3 to the 5th power is equal to 243, but in Python, if we do log base 3 of 243, it's actually going to give us 4.999 repeating. So we'll keep that in mind as writing the code, but that's really all there is to it. So if n is less than or equal to 0, we can immediately return false, because there's no number that we can raise 3 to that's going to give us a negative number or 0. After that, we're going to find out if x is a whole number by rounding log base 3 of n and subtracting log base 3 of n from the rounded version. Then we're just going to return whether the absolute value of that difference is less than 1/8 to the negative 10th, or in other words, if it's really, really close to 0. And we take the absolute value because x could be a little bit above or a little bit below the whole number depending on the floating point operation. And that's it. This solves power of 3, but not only that, if we take the log base 3s and change them to log base 4s, this also solves power of 4. And if you don't like doing math and logarithms, don't worry. There's a lot of different ways to solve these type of problems. I just wanted to show this one as well. And the time and space complexity of this solution are both constant because we're not using any data structures or loops, just a couple of math operations. If there's any other problems you want me to solve, leave them down in the comments. Otherwise, don't forget to like and follow for more.